Let's take a look at section 8.1. The square root property is what we're going to start with in this section. And this property basically says that if I start with some algebraic expression, let's call it u, so it could be just a variable or it could be some expression, and if d is a non-zero real number, then u squared equal d has exactly two solutions. If u squared equals d, then u is either the square root of d or u is negative square root d. And another way that we write that is in the shorthand notation, u equals plus or minus square root of d. So this is called the square root property. Don't forget the plus or minus. So this is a fundamental idea. We do cover this in Math 70 in the previous course, and we review it again here. Now the new thing that we add to this in Math 80 is this idea of completing a square. So if I have an expression on the left of my, or one side of my equals, that can be written as x squared plus bx, then if I add on the constant, the square of b over 2, then that expression becomes a perfect square trinomial. X squared plus b over x plus the square of b over 2 is the square of the binomial sum x plus b over 2. So these ideas are the two ideals we're going to use to solve this set of equations. Okay, so if we want to solve 2x squared equals 50, we need to isolate what's being squared. All right, so let's use these ideas to solve these equations. So 2x squared equals 50. We're going to divide. We want to isolate what's being squared. The only thing being squared here is the x. There's no grouping. The square only applies to whatever's to its left. And in this case, that's the x. So we divide both sides by 2 to isolate the square. And that gives us x squared equals 25. And now what I want to point out is that this exponent of 2, which I'm going to put that in blue, when I lose this exponent of 2 on the x, then I, in place of that, get a plus or minus square root applied to whatever's on the real number. And remember, this has to be a real number for me to use this property. So I get a plus or minus square root of 25. And I lose the exponent of 2 on the left. So what I want you to notice is that in exchange for this blue exponent of 2 on the left, losing that costs me the application of a plus or minus square root to whatever was on the right side or the other side of the equation. So x equals plus or minus 5. The square root of 25 is 5. So my solution set in this case is the set that contains a negative 5 and a positive 5. So in my math lab, you'll have to give the solution set for these, and the answers will need to be listed separately. Okay, so let's look at the second problem. Let's get some more practice with the square root property. So 4x squared equals 20. I want to isolate whatever's being squared. In this case, that again is x. So I'm going to isolate the x squared by dividing both sides by 4. And I get x squared equals 5. And then if I want to eliminate the exponent of 2 on the x, I have to apply the plus or minus square root to whatever's on the other side. And in this case, of the equals, in this case, that's a 5. So my solution set is the set containing negative square root of 5 and positive square root of 5. There's my result. So that's my solution set. And in my math lab, you are going to have to list those solutions separately as I'm doing here. Okay, so now we're going to step it up a little bit. Now we have to do more than just divide to isolate the radical. I have to subtract a 9 from both sides of the equation first to isolate what's being squared. So I have 4x squared equals negative 9. And then the square is still not isolated. It's a little more isolated than it was, but it's not completely isolated. And so to get the square isolated, I again need to divide. And again, I'm dividing by 4 in this case. So x squared is negative 9 over 4. And just again to make the point and to try to show the connection, I'm going to put this exponent of 2 in blue. So when I eliminate the exponent of 2 applied to the x on the one side of the equation, I have to apply plus or minus square root to the real number that's on the other side of the equation. And that happened to be a negative 9 over 4. So the thing to keep in mind here is that you have, when you're using the square root property, whatever you're squaring has to be set equal to a real number that's not 0. You can't have any variables on the other side of this equation. So this is plus or minus the square root of 9 over the square root of 4 times the square root of negative 1. And that step I just wrote is fine if you do that step mentally and don't have this written, but go directly to this step, which is plus or minus 3 over 2. The square root of 9 is 3, the square root of 4 is 2, and the square root of negative 1 is I. So this is plus, this solution set has the numbers negative square root of 3/2 I, negative 3/2 I, positive 3/2 I. I may have been saying something I didn't mean to say there. So negative 3/2 I and positive 3/2 I. So that's my solution set. All right, so we step it up a little, and this time, instead of just squaring a variable, we're squaring an expression, and that's fine. I do notice that my expression that's being squared is isolated. There's nothing being multiplied or divided by what's being squared. Nothing is being added or subtracted to what I'm squaring. So I'm ready right off the bat to apply the square root property. So I have the square of x plus 2 equals 11. And notice that means x plus 2 equals plus or minus the square root applied to 11. Now, if this radical was not in simplest form, I would make sure to put it in simplest form. But it is in its simplest form. You can't simplify this radical. So what I'm now going to do is I'm going to add a negative 2 to both sides of the equation. And typically you're going to put something like this in front of the radical expression that may be on the other side. So x is negative 2 plus or minus the square root of 11. So my solution set in this case is the set that contains negative 2 minus the square root of 11 and negative 2 plus the square root of 11. So that is my solution set. Those are the two solutions. All right, similarly, we're going to solve this one. We have the square of the difference, x minus 5, equal to negative 6. So when we drop the exponent of 2 on the x minus 5, we have to apply plus or minus square root to whatever is on the opposite side of the equals. So x minus 5 is plus or minus the square root of negative 6. So I am going to add a 5 to both sides of this equation. And I wind up with x equals 5 plus or minus, and let's simplify the square root of negative 6. That's the square root of 6 times the square root of negative 1. You cannot simplify the square root of 6, so that's plus or minus square root of 6i. So this is x equals 5 plus or minus the square root of 6i. And make sure that I is not under the radical. Sometimes what you'll find, to make sure that the I is not accidentally put under the radical, you'll find that the I is often, when I is being multiplied by a radical that doesn't simplify to a rational number, a lot of times the I is put in front of the radical. So the solution set is 5 minus I times the square root of 6, 5 plus I times the square root of 6. And that's my solution set. Okay, so